A 5 kilo wooden crate is dragged along a surface, which has these friction coefficients, and released with an initial speed of 5 meters per second. And we're asked to calculate the maximum distance travelled by the crate. So to do that, we can use the work kinetic energy theorem. So as we can see, the normal force and the force of weight are always perpendicular to the displacement vector, so they do no work, and only the force of kinetic friction does work. So that will be minus FFK multiplied by D max is equal to the change in kinetic energy, which is 1/2 by the mass of the wooden crate by the final speed squared minus the initial speed squared. So when the crate reaches a maximum distance, the final speed is 0, and the kinetic friction force is basically the kinetic friction coefficient by the normal force, which we can obtain by vertical equilibrium. So that would be the mass by gravity, and then by D max is equal to minus 1/2 mv0 squared. And if we cancel out m and substitute for the kinetic friction coefficient and the initial speed, then we can calculate D max, which is 3.2 meters.